Hello everyone and welcome to Math Steps. Today we are going to learn about experimental probability. We can estimate the probability of an event by experiment or by using data. So today you are going to focus here. We are going to estimate the probability of an event by experiment. Now, the experimental probability of an event is the ratio of the number of times that the event occurs to the number of trials. Remember, the number of times, so it's going to be this one. So number of times that event occurs over, and this is what the ratio means, over, so it's a fraction over the number of trials. Now, let's have a look what this means. The table shows the results of a spinner experiment. Find the experimental probability spinning a 4. Spinning a 4. As you see, the spinner has 4 numbers on it. And if you look across, you can see that spinning a 4, so the number of occurrences is 14. And the totals, if you add another box here, you can write the total. So the total frequency is 50. So them two make 30 plus 20, 50. And spinning a 4 is 14. So the probability, it is going to be 14 over 50. And both of them make, so if you can express this as a decimal or as a percentage. As a percentage, if you want to change this to over 100, it's going to be 28%, 28%, or 0.28. So you can express the answer as a decimal number or as a percentage. Let's have a look at another example. Right, the table shows the results of a spinner experiment. Find the experimental probability spinning a number greater than 2. So greater than 2, then it's going to be a 3 and a 4. So what is the probability spinning a 3 or a 4? Now, probability of spinning a 3 is 19 over 50, and spinning a 4, it is 14 over 50. Okay, both of them, the probability to get in a 3 or a 4, it is 33 out of 50. And if you want to change this to a percentage, this is going to be 66%, and to decimal number, obviously, is going to be 0.66. Let's have a look at another example. The table shows the results of choosing one card from a deck of cards, recording the suit, and then replacing the cards. Okay, replacing the cards. Now, find the experimental probability of choosing a diamond. So we're going to have a look at the number of occurrences for the diamond. It is 9. And the total of 5 plus 9 is 14, 20, 21, 26. So it's going to be 9 over 26. The probability of choosing a diamond, 9 over 26. Let's have a look at another example. Lovely. Now, it's exactly the same question, but we need to find the experimental probability of choosing a card that is not a club. It is not a club. Right, now, how can you do this? Of course, you can see now. We can do this in 2 different ways. The first one, and the one that we've just learned, is not a club. So what is not a club? It's a heart, diamonds, and spades. So we have 5 plus 9 plus 5, 19. So the probability that is not a club is going to be 19 over 26 is the total. Okay. Or the other method that you can do this one, it is called by a complement method, which is the method that we know that the total of all the probabilities has to add up to 1. So 5 over 26 plus 9 over 26 plus 7 over 26 plus 5 over 26 equals 1. This is equals 26 over 26. And so the probability of not a club, it is going to be 1 take away 17 over 26. All right, so take away from the 1. And the answer, of course, is 7. So I'm sorry, 1 take away 7 over 26. Eventually, the answer is going to be 19 over 26. So we get the same answer. So you can do it by adding all the cards that are not a club and dividing by the total, or by complement, so taking away what is a club from 1. Right, and here, this is your independent work. It says, in a box of 25 switches, 3 are defective. What is the probability of randomly selecting a switch that is not defective? Again, you can use both methods that I just explained. You can use the complement method, taking away from 1, or finding out how many of them are not defective. And then number 2 says the table shows the results of rolling a die with unequal faces. Find the experimental probability of rolling 1 or 6. So here they have the occurrences. 1 or 6. 1, so you're going to look here, and or 6, you're going to look there. And then as I explained before, or, and I will explain this in my next video, means to add. So have a look. And this is the last bit of today's lesson about experimental probability. In my next lesson, I'm going to show you more examples of probabilities. So thank you very much for supporting my steps. Have a lovely day. Bye-bye.